Today we will be answering the tower height question. The tower height question is, a communications tower is on top of a nearby mountain. From a position 4.1 kilometers away from the base of the mountain, the angle of elevation to the bottom of the tower is 13 degrees, whereas the angle of elevation to the top of the tower is 14 degrees. Find the height of the tower to the nearest meter. We also have an illustration to the right. This is what we expect from a student as an A standard response. We have the question itself, the illustration, we then have the students working out, as well as a final answer. The first step to answering the tower height question is identifying the two right-angled triangles in the illustration. Here we have labelled triangle 1, it's outlined in red, and triangle 2 is outlined in black. As you can see, we've clearly labelled the two different sized angles, one being 13 degrees and the other being 14 degrees. Both have a length of 4.1 kilometres, as well as the other length being an unknown, or x. Triangle 1 has an angle of 14 degrees. This is also known as theta. It has 4.1 kilometres as the adjacent side, and the opposite side is x, or the unknown, which is what we're trying to figure out. From this, we can identify that we can use the rule tan of theta is equal to opposite over adjacent, or opposite divided by adjacent. We then substitute in the known information. Tan of 14 degrees, which is what theta was, is equal to x, which is the unknown side, divided by 4.1 kilometres. We want to get x on its own, and in order to do so, we must do the opposite of division to cancel out the x on the right-hand side and to move it over to the left-hand side. The opposite of division is multiply, and as you can see here, we've got x on its own, which is equal to 4.1 kilometres multiplied by tan of 14 degrees. Here we have the answer as x being 1.022 kilometres. Once we've figured out the first triangle, we use the same process to figure out the length of the unknown side for triangle 2. Triangle 2's angle is 13 degrees, which is also theta. In relation to theta, we have the opposite angle being x, which is the unknown. We also have the adjacent side being 4.1 kilometres, which was the same as triangle 1. From this information, we can use the tangent rule. Tan of theta is equal to opposite over adjacent. We then substitute in the known information, which is tan of 13 degrees, which is also theta, is equal to x divided by 4.1 kilometres. We do the same as we did for triangle 1, and in order to cancel out the x on the right-hand side and move it over to the left-hand side, we must do the opposite of division, which is multiply. As you can see here, we've got x is equal to 4.1 kilometres multiplied by tan of 13 degrees. The answer is x equals 0.946 kilometres. Both the answers for the unknown sides of triangle 1 and triangle 2 were answered into kilometres. However, the question states that we must find the height of the tower to the nearest metre. There are 1,000 metres in a kilometre. So, to convert from kilometres to metres, for triangle 1, the answer was 1.022 kilometres. If we multiply that by 1,000, it will equal to 1,022 metres. If we do the same for triangle 2, which is 0.946 kilometres, multiplied by 1,000, it'll equal to 946 metres. Here we have both converted the triangles from kilometres to metres. To determine the height of the tower, we must take away triangle 2 from triangle 1. Once it's been converted to metres, we've got 1,022 metres minus 946 metres is equal to 76 metres. Therefore, the height of the tower is 76 metres. Thank you.